management, distributed tracing, and migration tools that all help reduce the complexity of running and managing applications at scale. We are also aware that organizations need to handle a growing number of clusters and in parallel manage security, compliance, and costs, everything under one roof. And that is where OpenShift Platform Plus comes into play, with a central container registry, scalable distributed storage services, multi-cluster management, and security in place. All in all, you are free to decide whether to consume this stack as a fully managed service with our public cloud provider partners, including AWS, Microsoft's Azure, Google Cloud, and IBM Cloud, or alternatively, self-manage it. But there is more. Red Hat Application Foundations, OpenShift Developer Services, and OpenShift AI provide additional capabilities to this current platform, making it even more open and hybrid, as well as fulfilling different user needs and more complex use cases. And all this is available to you today. And with this context in mind, let's now switch topics and let's talk about community. Marcus, next slide.
Thank you, Vanessa. And I am absolutely honored to open today's show with a big announcement. As we announced our intention in November to apply the Podman family of projects and Podman Desktop to the CNCF sandbox, we now have the final votes in. And both families, both projects, and all the aligned sub-projects have been thankfully accepted. And we're pretty excited to work with the CNCF on our further contributions, making sure Podman Desktop in particular becomes the best container developer tool out there. So that's for the first big announcement today. Over to the next speaker. Thank you.
Hi, good morning. So with OpenShift 4.18, it's based on the upstream CRYO 131 and Kubernetes 131 or Eli. Kubernetes 131 has a number of enhancements intended to improve overall traffic distribution, resource management, and security. So the ingress connectivity reliability enhancement for the kube proxy graduates to stable, and this marks a significant improvement to handling ingress connectivity for endpoints on terminating nodes or nodes with an unhealthy kube proxy. This is beneficial for admins who are looking to limit unexpected traffic drops during node shutdown. Additionally, there are two other features graduating to stable, which focus on deployment stability. The first is random pod selection during replica set downscaling, which will help maintain the balance of pods across failure domains. This will lead to a more balanced pod distribution in high availability environments. And additionally, there is the unhealthy pod eviction policies for pod disruption budgets. This will allow admins to specify actions, for pods that are healthy but not yet ready, providing them with a little bit more granular control over pod eviction processes. And finally, graduating to beta is the support for multiple CIDR ranges, multiple service CIDRs. This will resolve a number of challenges related to IP exhaustion in large or long-lived clusters by allowing cluster administrators to dynamically modify CIDR service ranges without downtime. Next slide. So now let's talk about the improvements we have downstream. In OpenShift 4.18, we're pleased to announce a number of product improvements that were driven by customer request. This slide shows the top requested enhancements delivered in this release. Firstly, we have the GA support for server message block container storage interfaces. So now customers in a Samba or Microsoft environment can leverage their existing storage infrastructure on OpenShift. Additionally, there are a number of networking related improvements, including user-defined networks. This is a first of its kind, highly demanded Kubernetes networking feature that will allow cluster and project admins to define isolated by default networks for pods and virtual machines. This is especially useful in OpenShift virtualization use cases. Additionally, support for custom IPv4 subnets on OVN for bring your own VPC deployments gives admins the ability to customize OVN networks at install time. A useful feature for cluster admins who might need to deploy a cluster onto a pre-existing VPC. Finally, we've expanded our bare metal support even further in the cloud with support for OpenShift bare metal and OpenShift virtualization in both Oracle Cloud and Google Cloud platform. Thanks. Next slide.
Thank you, Nick. In this section, we will highlight key OpenShift 4.18 features before looking into the broader release. First, a summary. So OpenShift 4.18 brings enhancements to the core platform and improvements for virtualization and security use cases, which all consolidate the user experience across the hybrid cloud. Let's start with OpenShift Core. With the 4.18 release, you can benefit from the Operator Lifecycle Manager v1, which provides improved security and GitOps integration. Moreover, especially if you deal with sensitive workloads, with OC Mirror v2, you can manage your container images with increased performance and security. Another news is that with the upcoming 4.18 release, both OpenShift on bare metal in Google Cloud Platform and in Oracle Cloud Infrastructure become generally available, as well as Oracle's on-prem offerings C3 and PCA, providing you with more choice on greater hybrid cloud innovation. But it's not yet over. On top of all of this, you can make use of highly customizable network configuration options with enhanced user-defined networks, also for OpenShift virtualization. And there is so much more. There are other enhancements that help fulfill today's growing virtualization demands, and those include OVE, OpenShift Virtualization Engine, Red Hat's lead virtualization platform, exclusively focusing on virtualization workloads, coupled with VM storage migration, which becomes generally available. Security-wise, the focus for this release is enhanced secrets management. We continue to work on boosting security on OpenShift, simplifying operations, and reducing administrative overhead costs related to clusters. The new set of security features includes the general availability of the Secret Store CSI driver operator that allows to seamlessly manage credentials and secure secrets. And now, let's take a closer look at the spotlight features, starting with the networking. So next slide.
Thank you, Vanessa. Okay, at OpenShift 4.18, we are pleased to announce the general availability of user-defined networks, or UDNs for short. Traditionally, the cluster pod network would be a monolithic layer 3 network topology across cluster nodes, and if you wanted a different network, you had to load one or more additional CNI plugins to do it. With user-defined networks and newly added VRF support, we give you more control on the segmentation of that traditional pod network and the ability to carve out additional isolated by default layer 2, layer 3, or local net networks for your pods and virtual machines. This means, for example, you can create a flat layer 2 network across your cluster for live migration of your VMs. Those VMs can be assigned a static IP on the network before their creation. And with the added BGP integration, those VMs can be directly referenced from outside the cluster without requiring any NATing at the cluster's edge. Overlapping IPs within the different UDNs are handled by Open Kubernetes so that each UDN is not only isolated, but its subnet assignment is independent of any other UDN. This new capability is native to our default networking of Kubernetes, also accepted as a CNCF sandbox project, by the way, and requires no additional plugins. How you use them to carve out tenant spaces is up to you. One or more namespaces per UDN, or multiple UDNs with a single namespace. All UDNs have support for cluster IP services and external services and support Kubernetes network policy. Tony, next.
Thank you. Operator Lifecycle Manager is a cornerstone of OpenShift, driving significant ecosystem growth. Now, based on your feedback as the ecosystem mature, we are excited to introduce the next-gen OOM v1. Key enhancements include a consolidated cluster extension API and declarative workflows for easier GitOps integration, enabling automated deployments and zero-touch provisioning, reducing the risk of human error. Continuous reconciliation and opt-in rollbacks, ensuring proactive issue resolution and improved reliability. The granular update control allows you to define a desired version and optionally enable automatic Z-string updates for critical security patches. And tightened security through user-provided service accounts, minimizing OOM's required permissions and improving the overall security posture. While OOM v1 initially supports a select set of operators, we are actively working to expand the compatibility. The now classic OOM v0s remains fully supported throughout OpenShift 4's lifecycle. We encourage you to explore OOM v1 and provide us with your valuable feedback. Next slide, please. So for those of you working in air-gapped OpenShift environments, managing container images can be a real challenge. OC Mirror has been a valuable tool in addressing this, and with v2, we've taken it to the next level, focusing on performance, flexibility, and security with key enhancements, including enhanced security by supporting enclave environments for sensitive workloads. Granular image deletions allow more explicit and precise control over image deletion to optimize storage. We've improved performance with intelligent caching to reduce mirroring times and network bandwidth consumption. For simplified application stack management, you can now also mirror your Helm charts alongside your container images with OCMirror v2, including enclave environments. And lastly, proxy support allows you to leverage existing proxies and pull through caches in your infrastructure, optimizing network traffic and improving efficiency. We encourage you to download the latest release to experience the difference and provide us with your valuable feedback. So with that, I'll hand it over to Peter for virtualization.
Thank you, Tony. As you can imagine, 2024 was an awesome year for virtualization here at Red Hat. We delivered a lot of cool functionality, and we're actually counting on the accelerator. 2025 is going to be another exciting year for us as well. You're going to see a couple of things, as Mark mentioned earlier. User-defined networking comes to OpenShift, and virtual machines on OpenShift are good citizens of the OpenShift platform. That means we can take advantage of user-defined networkings right away for basic multi-tenancy for VM applications, but you can also extend this across different clusters. As new capabilities come into user-defined networking, in terms of IPAM and things like that, you'll see that incrementally be available for virtual machines as well. The other thing that we delivered and is now generally available is storage live migration. And this is a great building block capability that allows you to move VMs, the storage, live to different pieces of storage in your environment, whether it's a different storage class on the same storage array or a different vendor if you've got a storage lifecycle event happening. And just a teaser, this is actually a building block capability that you can use in production in 4.18, but it will also enable some cool things that we're going to deliver in future releases. One of the other things that we've also seen is the availability of OpenShift and VMs on OpenShift on other public clouds. So the newest ones of Google Cloud Platform and Oracle OCI, those will be available as tech preview in 4.18. And as we talk to customers, though many of them are running their virtual machines on-prem, they want the flexibility to move to different public clouds, depending upon what subscriptions they may have or other things they may have available to them. And that flexibility that OpenShift has also extends to virtual machines in OpenShift. As I said, virtual machines are good citizens of the OpenShift platform, but some of the things that we're doing in the OpenShift virtualization team actually go back into OpenShift itself. So we have some basic VM workload balancing capabilities that use the requests that are part of the system now. And we've actually enhanced that in the developer preview to use the actual usage. And as this capability becomes more refined and gives you more control over your optimizations, that can also be used by third-party tools in addition to OpenShift itself. One of the last things that we have that's probably the most visible is the screenshot here is if you're into a ClickOps world where you have, you want to actually see inventory and check on things manually and visually, that's absolutely possible to do with the tree view of the inventory. And this gives you different dimensions of looking at VMs and namespaces, and it all covers the role-based access that you have in your cluster. So you can see the things that you have access to. And if you're the cluster administrator, you can actually see everything. Now, in addition to all these product changes that you're seeing, next slide, please. We actually have some subscription changes coming that have been announced and are available as well since the beginning of the year. And that's OpenShift Virtualization Engine. And this is a pared down version of OpenShift. It's actually the same OpenShift product, but the entitlements are limited to virtual machines only. A couple of changes here, which is we've actually bumped the 64 core entitlement to 128 cores. As everybody can imagine, the machines just kept getting bigger and bigger, and we want to make sure that you can take advantage of those for your virtual machine workloads as well. This new entitlement, this new offering in this of OpenShift allows you to also use advanced cluster management to manage your virtual machine workloads, and also take advantage of the strong workload monitoring and logging that's built into the OpenShift platform for your VM workloads. Now with that, like I said, virtualization's been very exciting, and look for some very cool stuff landing in 4.18. We'd love to hear your feedback. I'm going to turn it over back to Nick to talk about some security.
Hello again. Thank you, Peter. So our efforts to improve the security posture of OpenShift 4.18 fall into 3 different categories: network security, workload security, and cluster stability. The release of Cert Manager 15, which will be available with OpenShift 4.18, includes the Istio CSR feature, which will enable the seamless integration with OpenShift Service Mesh, allowing users to secure the service mesh's workload and control plane network communications with an external certificate management system. Additionally, the Cert Manager's issuer plugin model means that administrators are able to bring their own PKI issuer of their choice for better compliance and security. Additionally, we're excited to announce the GA of Secret Source CSI driver and operator with 4.18. With this release, workloads on OpenShift clusters can seamlessly connect to an external secret manager of your choice. Secrets are then stored in an ephemeral volume mounted to each pod rather than running as a Kubernetes secret. This will make the cluster completely secret unaware, and is extremely valuable to cluster admins who have to adhere to strict compliance or governance regulations. Finally, we have improved the stability of OpenShift in 4.18 by enabling automatic recovery of expired certificates on OpenShift clusters. Now newly created single node OpenShift clusters can be shut down and restarted without requiring a backup. Additionally, high availability self-managed clusters in the cloud can be suspended for up to 90 days and recovered with just a certificate signing request approval. This should highly increase the efficiency and reduce downtime of restarting a cluster gracefully. Now on to Gaurav. Thank you. Next slide.
Hi, OpenShift Lightspeed is a generative AI-based chat assist. It has been in tech preview, and this is another tech preview release where we have listened to your feedback and incorporated your feedback in another tech preview release. So these are things like will include OpenShift 4.18 knowledge into the chat assistant, will support ARM-based architecture. Previously, you have to wait for whole response to capture and show it to you, but now, just like another ChatGPT, you will see line-by-line response printed on your screen. It is now designed for FIPS, which is more specifically FIPS 140. And now when you open the OpenShift Lightspeed on top of your virtualization top of a VM, it understand where it has been opened, and you are able to import all the VM objects like YAML logs, even right into OpenShift and ask follow-up questions. YAML, now we have made the YAML import easier. When you ask to generate YAML from OpenShift Lightspeed, there you can import that YAML right into the YAML editor of OpenShift. Next presenter, please.
Thank you, Gaurav. So observability signal correlation with its troubleshooting panel in the web console is available as an enhanced technology preview. By applying a set of rules, the tool finds relationships between Kubernetes resources and other signals from multiple heterogeneous data stores, reducing the complexity of handling different labeling conventions and query languages, and most importantly, empowering users to find the root cause of issues faster. The most recent announcement of the tool is trace support that you can test out by installing the Cluster Observability Operator 1.0 version, soon available. For example, starting with a pod, you will be able to visualize its correlated traces. Stay tuned as we are working on a GA release, and now let's switch gears with AI accelerators. So over to Erwan, so next slide.
Hello. So with Red Hat OpenShift, you can run and manage AI applications anywhere across the hybrid cloud. So we are providing a ready-made and highly optimized platform for the AI accelerators. With our Red Hat ecosystem partners, we are giving more choices with OpenShift 4.18. So first, for NVIDIA GPUs. So the NVIDIA GPU operator now supports the NVIDIA H200 NVL. So this GPU introduced the support for a new 4-way NVLink interconnect. So instead of taking big server EdgeX, you can use the H200 NVL to run large language models without NV switch, and it's a cost-efficient solution. A new feature also about OpenShift virtualization with vGPU time slice, now GA and supported. So you can run virtual machine on the C-series vGPU. So it's the compute series for your high-end GPUs, including the A100, H100, H200. We have worked with NVIDIA and Oracle to provide on Oracle Cloud Infrastructure the support of bare metal compute chips, so A100, H100. So these OCI instances are providing bare metal performance with low latency networking. And to finish with NVIDIA, so we are continuing the journey of Grace on ARM support with Grace Hopper GH200 NVL2. So this system has two Grace Hopper, and it's available in the catalog. You can find, for example, the HPE DL384 Gen 12. Moving to AMD, so now the AMD GPU operator is GA, so it was already available in the catalog, but now GA on the certified. It supports AMD Instincts MI210 on MI300X. So if you take the MI300X, it's an 8-way GPU, so you can use 1.5 terabyte of VRAM per server, so providing additional options. We continue with Intel. So after Gaudi 2, now we support Intel Gaudi 3 with the Intel Gaudi base operator. And I'm finishing with a new accelerator, the IBM Spire. So the IBM Spire accelerator is now supported. You will find the catalog, the AIU operator. So now I will hand it over to Adel.
All right, thank you, Erwan. So we're going to move to scale and OpenShift clusters at scale, starting with hosted control planes. So the first interesting feature that we're shipping is host tenancy support was exposed for our existing AWS providers configured by the node pools. So usually you would, when you use the cloud, you're renting a VM and you might be sharing that with other users. But what if you want to rent your own entire building, your own dedicated host? You can do that now via the node pool, which is a declarative way to configure things on OpenShift using hosted control plane, and configure the node pool to use dedicated underlying host to prevent other tenants sharing the same building with you. So you get your own building on AWS with node pools. And we're also shipping a preview experience for you to try OpenStack as a provider for hosted control planes. We're looking for feedback here, so we're exposing this to get feedback and to get your input on your use cases to be able to propagate this further to tech review. So looking forward to your feedback here. And an additional feature here is heterogeneous node pools, except this time with the Asian provider. Historically, we've used the Asian provider to provision bare metal machines, which is a GA feature, or even non-bare metal machines for you to experiment with virtual machines on vSphere, Nutanix, or other form factors and providers. This, which was tech review. Now we're also expanding on the Asian provider, giving you the ability to share the same cluster between node pools that are on x86 and node pools that can be on Power or Z systems, which gives you more flexibility into how you deploy your nodes and your workloads. Finally, you're going to be able to deploy hosted control planes alongside standalone with a condition of up to 3 hosted clusters. So this is to address the concern or the use case where you have a limited capacity for compute and you want to start experimenting with hosted control plane on bare metal machines, for example. So we're giving you the ability to test and prototype and even deploy up to 3 hosted control planes. And then if you want to expand further, you can still add additional nodes to your cluster and scale out the nodes in your cluster. With that, I'll hand over to the next presenter. Next slide, please.
Thank you, Adele. Yep, and I'm going to build on some of the items that Adele and Peter shared around hosted control planes and virtualizations as I talk about advanced cluster management. That's ACM, and this is version 2.13. We're going to continue on the virtualization theme here. We all know virtualization and kube is a thing, and now it's time to make it a thing at scale. So with ACM 2.13, you get more control and insights into virtualization in your environment. This builds on the 2.12 ability to create and destroy VMs directly from the ACM console. So now with ACM 2.13, we've added the right sizing virtualization dashboards. This complements existing namespace right sizing dashboards and cluster health dashboards. This gives admins a single observability pane for clusters and VMs alike. As well, ACM 2.13 added policy-based backups of virtual machines. As well, finding and managing VMs in your fleet from ACM search will be enhanced with direct console action to each running VM. To recap, you can search for any VM across your fleet, find it, and manage it all from within ACM. Next slide, please. ACM continues to work towards solving problems in the configuration management space with policy-based governance. We're providing a user experience for Kyverno and Kubernetes validating admission policy and the governance user interface. Kyverno and validating admission policy are automatically discovered and displayed in the discovered policies user interface. Kyverno policies will display relevant audit violations. And then for clarification, Red Hat support for Kyverno as a runtime policy engine is not being offered. Kubernetes validating admission policy, VAP, is fully supported as of OpenShift 4.17. We're improving the pre-deployment validation experience for open cluster management policies. This is a tech preview. So we're making it easier to continuously validate the behavior of your policies prior to their deployment to clusters. So writing test cases, using the policy tools like the CLI dry run command. This will help you verify the desired behavior when creating new policies or updating them. And as a best practice, you can integrate these tests into your CI pipeline. As part of your GitOps-driven policy and code workflows, this enhanced reliability and safeguards. As well, we're uplifting the gatekeeper operator to 3.18. Next slide, please. And then we have cluster API operators evolving within the OpenShift container platform ecosystem. So with the OpenShift container platform related components like Hive, Assisted Installer, MCE are working on supporting CAPI. There are requirements from customers now to support CAPI in the ACM operator. The OpenShift CAPI operator is a Kubernetes operator built to enable cluster administrators to manage the lifecycle of CAPI providers. Specifically, it supports lifecycle management of ROSA-hosted control plane clusters within a hub cluster using a declarative approach. CAPI operator goal is to enhance the user experience in deploying and managing ROSA-hosted control planes. And in the future, Azure Red Hat OpenShift hosted control planes, the RO. This will help with simplifying daily tasks and streamlining automation workflows through GitOps. Lastly, the Submariner add-on now supports hosted control planes in bare metal. I'd like to hand it off to our next speaker for advanced cluster security, Anjali Talang. Thank you.
Thank you, Brad. In December, we brought you a very feature-rich ACS 4.6 release, and we continue the same journey with more amazing features in ACS 4.7. This will come alongside OpenShift 4.18. So let's take a brief overview of these features. In the area of vulnerability management, we are very excited to introduce SBOM generation as a tech preview feature. To effectively manage software supply chain security, Scanner v4 in ACS will support generation of SBOMs on scanned container images. These SBOMs offer a detailed and comprehensive inventory of all software components, dependencies, libraries present in the scanned images. Additionally, with ACS Scanner v4, we will now enrich vulnerability data with EPSS, which is Exploit Prediction Scoring System scores. The EPSS scores provide a data-driven estimate of the likelihood that a specific vulnerability will be exploited within the next 30 days. This is an extremely useful feature that allows organizations to prioritize their vulnerability remediation. Soon after ACS 4.7 releases, we will also release ACS integration with ServiceNow Container Vulnerability Response Module. This integration allows ACS detected vulnerabilities in container images to flow into ServiceNow Container Vulnerability Response Module. And this helps with efficient tracking and resolution. And lastly, we are providing an ACS Backstage plugin that can be dynamically provisioned within the Red Hat Developer Hub. This will allow developers to easily assess vulnerabilities and look at security information about their application and take necessary remediation actions. We will continue to enhance this in upcoming releases, but we are releasing this as a tech preview in the current version. Looking at some of the improvements, the area of platform support, ACS internal components now use MTLS to talk to each other, to communicate with each other. And with this release, we introduce certificate auto rotation for ACS secured cluster, which will greatly help customers to easily manage their certificates for ACS components. Additionally, we plan to separate the bootstrap credentials used in the init bundle from the certificates used for internal component communication. ACS will now support using short-lived credentials with workload identity to connect with Azure services, such as Azure Container Registry. Now, we've already provided similar functionality for AWS and GCP since ACS 4.4. With the release, we also provide documented usage of short-lived OIDC credentials from Microsoft Entra ID for machine-to-machine authentication. In our previous releases, we've already documented generic OIDC integration, but in this specific release, we wanted to bring in Microsoft Entra ID, which is widely used by customers. Next slide, please. In ACS Cloud Service, we continue to provide hardening features. With the new feature allowing access to authorized IP ranges only, we aim to restrict access to the ACS console and to the ACS API, allowing only users with specific company network IP CIDR ranges for the access. By doing so, we reduce the attack surface, ensure only trusted IPs can interact with the policy enforcement point, strengthen the overall security posture for compliance and regulatory requirements, and enable better control and visibility for administrators. Thank you, and next presenter for Quay updates.
Thank you. First off, for those still listening, welcome back to another episode of What's New. The Quay team is elated to highlight our latest updates that enhance overall storage support and intuitiveness in your user experience. First up, we're introducing basic artifact storage functionality for AI ML models as a tech preview. This collaboration with the OpenShift model registry team will allow you to store and manage your machine learning models, paving the way for seamless ML workflows. Now, let's talk about UI improvements. We know, a long time coming. Alongside focusing on key features that enhance the overall product experience, the team has been incrementally migrating new UI functionality from the old UI with the goal of defaulting this new experience this year. And lastly, we focus on making our user experience more intuitive by reducing the time and effort needed to use our product. Two such standout examples of this are improved tag and notification management, eliminating the need for manual intervention. In summary, we believe these updates will empower you to work more efficiently from your key AI ML workloads to speeding up your daily business operations. We look forward to hearing your feedback along our journey. I'll hand it over to Roger Florin.
Hello. I'm happy to announce that now we have Cluster Observability Operator generally available along this 4.18 release. So there's no doubt that the observability is the backbone of the OpenShift platform. And as such, unifying and simplifying this user experience has been our ultimate goal. So no matter the number of clusters you manage or where that cluster, that's where the Cluster Observability Operator comes into play. So with this latest 1.0 release, the Cluster Observability Operator will be our brand new single entry point operator for everything observability. So why should you consider this operator at all? Because it's now essential for making use of some of the observability UIs, some plugins, and some related analytics features, but also for creating these standalone monitoring stacks that are independent from the default in cluster monitoring. But it's not only that. With this release, we have seen earlier in the presentation from Vanessa, users can now benefit from an enhanced technology preview of observability signal correlation and the troubleshooting panel. And in addition to this, Red Hat Advanced Cluster Management in the ACM can now install COO on the hub to access a developer preview of the multi-cluster alerting UI directly in the ACM console. So this will be a kind of game changer feature as it will provide customers with opportunity to better navigate alert noise across the whole field under the one UI. So look out for cluster observability. There will be much enhancement coming. Next slide, please. So within the OpenShift monitoring stack, we have some updated highlights, and we introduced the ability for user-defined monitoring administrators to define these multi-namespace for Prometheus alerts. So this will allow for much more granular and flexible alerting that is tailored to a very complex workload. More on that, we have added on the Prometheus IO patterns is to enhance the performance, especially in environments with shared storage. So we optimize the patterns for Prometheus, and this improvement will help you reduce overhead and ensure a smoother operation. For Alert Manager, we added this long time coming, proxy integration. So now it will integrate seamlessly with common proxy settings, and that will simplify the configuration for your environments that rely on proxy for the network communications. Another big feature is that we have added support for collecting accelerator metrics, also enabling better insights into workloads that are utilizing the GPUs or other hardware accelerators. So, and config validation and feedback is one of the key things we also added for give you feedback and validation for your monitoring configuration. So that help you to reduce the troubleshooting time. And in general improvements, we added some custom metrics in the must-gather, runbooks and alerts, and the general monitoring stack components have been updated to the latest releases. So over to Jamie.
Right. Thank you, Roger. So Logging 6.2, we're continuing to release and refine our new logging series, the Logging 6 series, and this will be our next EOS release going along with OpenShift 4.18. So we have a couple of things that we're doing. We're continuing to refine the Logging 6 releases. In log collection, we will now have short-term token support for exporting logs to Google Cloud Platform using workload identity federation. So that's been a big request from customers. And as for log storage, in our previous release, we released a tech preview for OpenTelemetry semantic conventions in both log collection and log storage. And we're going to continue to refine that by optimizing Loki queries for those OpenTelemetry semantic conventions. Next slide, please. For the Red Hat build of OpenTelemetry, we will now have automated RBAC for OpenTelemetry components. So we'll be able to apply a more secure RBAC model, ensuring that customers can see the things that they're allowed to see within OpenTelemetry. We're also going to be able to export OpenShift monitoring metrics via OTLP. So we're adding kube stacks and host metrics as GA components so that you can send those off cluster in OTLP format as needed. As for distributed tracing, we're also introducing a fine-grained RBAC for stored tracing data. So users will be able to see things that they are authorized to see within their namespaces. We're adding support for IBM Cloud Object Storage for Tempo, and we're also improving the Tempo monolithic memory handling so that you'll be able to use Tempo in a much more fast and optimized manner. And with that, I'm going to hand it back to Roger.
So a short update on power monitoring. Like the latest development in Kepler and power monitoring is that we are trying to reduce the overhead. So within this release, that is also along 4.18, it will be released on the 5th of February. The next tech preview release, power monitoring 0.4. So we're trying to, as I said, optimize the performing and how we collect and process the power data. We also worked on the data accuracy and on the bare metal deployments, and we updated the machine learning model responsible for estimating the power consumption in environments where we don't have access directly to the hardware. Moving on that, we have some significant updates in the Kepler operator 0.15. We are looking into supporting the GPU support. And this is crucial because the growing use of CPU and AI and machine learning workloads. So accurately monitor their power usage and to maybe tokens to watts is going to be crucial for any backend administrator. So we are targeting the GA for end of April in 2025. And that means all the core features should be stable, production ready, and well documented. So these tools that we are producing now with Kepler Insights and are instrumental in supporting some of the sustainable research projects we are helping with. And that helps everybody as organization and researchers and measure and optimize energy and for all their green computing initiatives. So thanks for that. Then over to the next speaker, Ali.
Thank you so much. Hey folks, welcome to the OCP console section. So great news, in this release, we have leveled up our security by adding content security policies for the console. This is used as added protection from cross-site attacks. Also with this release, dynamic plugin creators could add their own policies, as you see demonstrated in the sample provided. The console now has the ability to report any plugins that break our security policies. Admins then have the ability to disable any misbehaving plugins. This will be behind a feature gate for this release to give plugin creators time to address any issues. For more info, please use the reference link at the bottom of the slide. Let's go to the next slide, please. All right, so we got some more exciting enhancements coming to the console. First off, we've updated the existing import YAML button in the masthead. It will now be a quick create button. It's designed for rapid deployment of workloads. Users have the option of YAML, Git, or container images. Next up, we added our first AI chatbot sample. This is for users who want to learn how to create their own AI chatbots on top of OpenShift. This Gen AI chatbot is deployed via Helm and comes with a full CI/CD pipeline. And finally, to remove all friction, users can run this on clusters without GPUs. Next, we added a few pipeline enhancements. First, support for colorized logs. And the next, we deprecated cluster task. Finally, if you haven't tried Lightspeed yet, we just made it easier to interact with the console by allowing users to quickly import their YAML to console from Lightspeed. Next slide, please. So for every release, we like to focus on direct customer enhancement requests called RFEs. For the first RFE on the list, we've added a console configuration to disable the Getting Started card on the overview page. This will give users back some valuable real estate and allow them to maximize usage of their dashboard. The next RFE gives users the ability to run a cron job immediately. This is very helpful when testing. To access this, users will see a new action in the menu on the list and detailed pages for the cron jobs. Next slide, please, and I'm going to hand this off to Marcus. Thanks, y'all.
Thanks, Ali. Let's take a look at some of the key updates in the developer tools ecosystem. We're starting with the OpenShift toolkit for VS Code and IntelliJ. We've made it easier than ever to activate the extension, and you can quickly set up your sandbox using single sign-on now. Plus, there's a brand new Helm UI page with tag-based filtering and a convenient way to pick different dev file versions. With the Quarkus for VS Code and IntelliJ update, we've added support for global namespace and multiple quote template routes, so you can organize your development however you like. We also have a data model template matcher, rogue data mapping, and overall better performance, especially in the VS Code extension. Finally, the language server protocol is still relatively new, but you can find it on the JetBrains marketplace and on GitHub. It got some important bug fixes. One thing I wanted to highlight here is a community demo using it, and it shows beautifully what it's capable of. So when you get your hands on the slides, make sure to check it out. Next slide, please. And onto OpenShift Dev Spaces with version 3.17 based on Eclipse Chase 7.92 will bring you a ton of updates. And again, it's just a selection of features here. Due to time constraints, make sure to point your phone at the screen, scan the QR code, and look at the full release notes. First off, we made the total number of running workspaces on the cluster configurable. This will help you keep your resources under control. We've introduced a way to specify which URLs are allowed to start, CDEs, which gives you a tighter security and more precise control over your environment setup. We've added an option to deploy operator-managed operands on specific cluster nodes, like the dashboard or gateway. This flexibility helps you ensure your workloads run exactly where you need them. All these improvements work together to streamline how you can create and manage development workspaces on OpenShift. Enjoy exploring what's new and be excited for the next releases. Next slide, please. Another brand new release comes with Red Hat Developer Hub version 1.4, which serves as the internal developer portal for OpenShift. On the core side, we've added middleware functions to the HTTP router, fully supported OpenShift Dedicated now, and expanded our support to cloud platforms. We've also moved Janus plugins to new homes in the Backstage community and under the Red Hat developer GitHub, which makes it a lot easier to keep them updated, and we're following community guidelines here. So make sure to check where you've got your plugins from. They have moved and they will continue to stay in the new places. We now have a brand new notification plugin that supports OpenTelemetry, so you can monitor your environments more efficiently. There's also a ton of updated documentation on how to convert and install dynamic plugins, which make it a ton simpler to customize RHDH. Finally, we introduced example AI templates, along with an example how to build your asset tracking with the Backstage software catalog, a great way to manage your AI assets and drive AI-infused development alongside with Red Hat Developer Hub. Next slide, please. And finally, let me introduce you to the latest version of Podman Desktop, which is 1.15. This got some minor updates in right before the holidays. The feedback form got a major redesign, so it's much smoother now for you to submit issues directly to GitHub for the team to take a look at. There's also a new experimental task manager that you can try out, which is perfect for testing. And if you're working with Kubernetes, you'll love the enhanced Kubernetes events feature that brings event tracking for node services and pods, so you can keep an eye on your local cluster. Another handy addition is SSH access to Podman Machine, letting you connect directly to your Podman machine right from Podman Desktop. And the real star of the show is actually bootable containers, which converts a standard container image into a fully bootable OS on a thumb drive. It's a great example of how container technology is expanding beyond the usual boundaries. What I did not mention here is the tutorials, and Stefan reminded me to make you all aware to go to podman-desktop.io and grab the tutorials, get your hands on, try out Podman Desktop, make sure you're giving all the bootsy the love it deserves. And final reminder, please do not forget to give us a star on GitHub. Seals still love collecting stars. So thank you so much. Don't forget to also check out developers.redhat.com. I guess now it's on to the next speaker. Jeff, thank you so much.
All right. Thank you, Marcus. Hello, everyone. This is Jeff from the Red Hat Runtimes team. I want to talk about a few Runtimes release features that will positively impact OpenShift users. First, I want to talk about the Red Hat build of Quarkus version 3.15, which was released late last year. A number of great improvements there, including Red Hat Developer Hub integration, which will make it easier to create new Quarkus applications with approved templates. There was a number of security improvements. So via Quarkus extension, you're now able to centralize the TLS generation and configuration. This is going to make it easier to manage and maintain secure connections across your applications. There was also a number of front-end web development improvements. So now we've got broader support for tools and libraries for better front-end web development. So support for Web Bundler, HTMX, and web components. And lastly, Java Flight Recorder extension was released now. So if you have containerized Java applications, you can monitor them on OpenShift using Cryostat. Next slide, please. Now I want to dive into some new updates for the Red Hat build of Keycloak 26, which was GA'd in late November of last year. Overall, these updates are designed to make identity and access management easier, flexible, more scalable. So first, we've got multi-organizations for multi-tenancy is now available. That's a big phrase. This simplifies identity management for SaaS platforms. So this makes it easier to manage customers, partners, and more at scale. For improved reliability, we've introduced multi-site high availability with active-active deployments on AWS. Also, from a user experience perspective, we've got persistent user sessions now, which keeps users seamlessly logged in even during system restarts. There's also now new hostname options that offer greater flexibility in managing and configuring domain names. We also have support for Java 21 now. So now developers can take advantage of the latest features and optimizations and security updates and align their applications with the latest enterprise standards. Lastly, we've also improved lifecycle support policies, which kind of gives our customers clear guidance and confidence for long-term planning. Existing customers that were using Red Hat SSO products, they now have an extended life cycle, which will be available via the ELS in June 2025 through 2027. Next up is Jamie.
Thank you. So for platform services, first we'll start with Service Mesh, which helps you create secure, reliable microservices with automated MTLS encryption, zero trust policies, and visibility with metrics and traces. We have some big news. Red Hat OpenShift Service Mesh 3.0 will be generally available shortly after OCP 4.18. It's based on Istio 1.24 and Quay 2.1 and is managed by a brand new simplified operator for Istio. A supported migration path will be provided for users of OpenShift Service Mesh 2.6. OpenShift Service Mesh 3 adds support for features such as Istio's multi-cluster topologies, and to provide peace of mind during upgrades, it adds support for Canary control plane upgrades. And last but certainly not least, Istio Sidecarless Ambient Mode will be available for developer preview with 3.0. OpenShift Service Mesh 3 will be supported on OCP 4.14. It's available now for technology preview, so please give it a try today. Next up, Harriet will discuss GitOps.
Thanks, Jamie. The latest GitOps release is version 1.15. If you're unfamiliar with OpenShift GitOps, it's based on Argo CD and Argo rollouts from the upstream Argo project and provides continuous delivery for things like applications, cluster config, or any other resources. As part of this release, the GitOps team have put in a lot of work upstream and downstream to make multi-source applications generally available. There are also two major updates for rollouts. You can now see a resources associated rollout directly in the Argo CD UI with the addition of the rollouts extension. And we've included the rollouts plugins feature from upstream, enabling you to use any of the available rollout plugins for traffic managers or metrics. We've also improved the isolation of applications with the decoupling of the service account privileges of the control plane and application syncs. Previously, the control plane service account needed to match the highest level of access privilege required by a tenant application. Now each is able to use its own service account and have different privilege levels. Finally, in this release, we have delivered 3 customer RFEs. Custom TLS certificates can now be stored in secrets. You can restrict the application set controller to create and update actions. And last but not least, we've added high availability mode for Rollout Manager. I'll hand over to Siamak to talk about pipelines.
OpenShift Pipelines 1.17 is released alongside this release of OpenShift. There is added support for multiple auth configuration for Git resolve. This is for customers when they are storing their distributable Tekton task in multiple Git repositories, and those repos require different credentials. One set of credentials is not sufficient for accessing all those repos, so we can define multiple of those credentials now in the configs of Tekton to be able to access those tasks automatically when they're pulled by the control plane. In this release, there is more of the pod template attributes are exposed as the default attributes that one can configure for task runs. Affinity Assistant is one of them. There is more of those, and one can set them that automatically they will be set on any task run that gets generated for a particular pipeline run when it's executing. There are more Prometheus metrics also introduced in this release for more granularity around namespaces, around pipeline, and if the customer is using pipelines as code around a Git repository. We have previously had a lot of these metrics available at the cluster level, and now we're just narrowing it down to be able to group them in a smaller units for namespace pipeline or a Git repository. Next slide.
OpenShift Serverless is an add-on operator that elevates OpenShift to OpenShift++ by offering better auto-scaling and networking for containerized microservices and functions. It is based on the upstream project Knative, and with 1.35 release, we would update it to Knative 1.15. With this release, we are making Golang functions as generally available using S2I build, expanding the language options available for developers. For your event-driven apps needs, we have added event catalog to Dev Console to document, visualize, consume, and manage events, making it easier for developers to build event-driven applications. In this release, leveraging KDA CMA, the platform now supports automatic scaling of Knative Kafka subscription And for serverless logic that provides capabilities for building complex workflows and orchestrating microservices, we have added seamless integration with Knative eventing for orchestration and capability to integrate with Prometheus for better monitoring support. We are excited for you to try out these new features, and we'd love to hear your feedback. Thank you. Next, please.
Builds 1.3 is released. This is based on the Shipwright upstream project, the evolution of build configs that exists in OpenShift. In this release, there is support for air-gapped environments and clusters that have restricted networks. And it is made also available for other architectures, ARM architecture and IBM Power. As tech preview, this release is FIPS validated. And another important area that many customers have been asking is simplifying how customers can run entitled builds. This is when they want to build an image using a Docker file, and inside that Docker file, they would like to install RPMs that are part of the rel content. So they would require an entitlement subscription to be able to do that. And those subscriptions are available automatically in an OpenShift cluster. It's just there are a lot of frictions how to get them into a build and use them in a Docker file. And using the shared resource CSI driver in builds, it helps the customers to be able to access the credential, the certificates for the entitlement that are already available on the cluster, and be able to mount them inside a pod that Shipwright is using for building an image. Alternative to this is that customers replicate those entitled certificates in every namespace on the platform, and those get refreshed every 24 hours, so they have to constantly do this. And this combination of the shared resources driver with Shipwright removes that overhead of constantly distributing and rotating those secrets. There are enhancements within console also brought into this release. The first one is build samples. So if somebody is creating a Shipwright build or modifying it, and they don't want to start from scratch, they can click on one of the samples that shows up in the editor and gets copied into the editor and modify that instead. There is a form-based build creation wizard also added in console that people will be presented with a form. They can just enter what's the Git repo, what's the target image to be built, and they don't have to deal with YAML if they are not a big fan of it. Next slide, please.
Thank you, Siamak. For providers, as already explained in the highlights, we are extending support for OpenShift on Oracle Cloud for 2 new on-prem services, Oracle Cloud at Customer and Oracle Private Cloud Appliance, as well as graduating bare metal support on Oracle Cloud Infrastructure. On the installation flexibility, we offer 4 use case driven onboarding experience that you might be familiar with already. Automated or installer provisioning infrastructure, where the installer controls the full installation end-to-end. Full control or user provision infrastructure, where the user is responsible for provisioning and maintaining their infrastructure. Interactive or connected experience via the assisted installer, which provides a web-based user interface to guide you during the installation process. And a local or disconnected experience via the agent-based installer to streamline the installation process specifically for restricted network environments. Next slide, please. Let me show you some of the most relevant features we have added specifically for users deploying OpenShift on cloud providers. So we have enabled support to rotate the bound service account signature keys that authenticate the cluster when this is deployed on cloud platforms. This supported procedure has been documented for both AWS, GCP, and Azure. Specifically for AWS, users can now specify IPv4 subnets during installation, allowing them to customize OV and internal networks when deploying OpenShift in a bring your own VPC environment. For Google Cloud, we are introducing user-managed external DNS support as generally available. GCP workload identity has been extended to support additional OLM operators, allowing users to securely authenticate and access Google Cloud resources without requiring long-lived credentials. And we have enabled support for the latest Google Cloud machine families and introduced the ability to run OpenShift on bare metal machines on this cloud, as we have explained before. For Azure, the cluster API provider will be tech preview in 4.18. There will be no impact for users until CAPI is generally available in OpenShift in a later release. We have also extended support for Entra workload identity for additional OLM operators, enabling secure and seamless authentication to Microsoft Azure resources without relying on long-lived linked credentials. And with this is all. Next, over Ramon now.
So for on-premises, let's start by bare metal. And starting in 4.18, now you can use the install config to add your NTP servers. Say that you get your hardware and they have the hardware clock to ahead or to behind. That's not going to be a problem anymore, because first boot, you're going to use the NTP servers that you specify in install config. Continuing with bare metal, you are going to be able to do on day 2, after the cluster is installed, to update the BIOS attributes, the firmware settings, right? This is a technology preview. This is possible to do today on day 1 during the cluster installation, but there were a few use cases where users needed to do this after the cluster has been installed, including, by the way, firmware updates. VMware vSphere, we are supporting in 4.18 multiple NICs on your VMs now, on the VMs that are your compute nodes for OpenShift, for example, to have dedicated networks to access storage or databases. This is a technology preview available in 4.18. And in this release, we are GAing support for multiple vCenters, adding a new layer, yet another layer of high availability. Nutanix, similarly to vSphere, we are adding support for the same reasons for multiple NICs in your compute nodes. And we're also introducing support for having and using a preloaded RHACS image from Prism Central, meaning that when you install OpenShift on Nutanix platform, you don't need to upload the CoreOS image from where you are installing it. It will be there and it will deploy right from the infrastructure, accelerating the installations by a lot. Moving to IBM, in a previous release in 4.18, we added support to add nodes to any cluster from an image. You create an image with our technology in the agent-based installer. You boot that image, and that image is specific for the cluster you want to extend. So now this is supported in IBM as well, starting in 4.18. And moving to multi-arc, in this release, we're adding automatic support to move your x86 control plane over to ARM nodes on AWS. It's automatic. You need to enable it, right? But automatically, you will be able to do this transition, for example, for saving costs in ARM flavors. You will also be able to do fine-tuning of how to distribute your workloads across different architectures. So you will be able to say whether some workloads will prefer ARM versus x86, etc., in a cluster with mixed architectures. And finally, multi-arc tuning the multi-arc tuning operator is now fully supported in hosted control planes. Next slide, over to Jill.
Thank you, Ramon. So for Shift on Stack on 4.18, we're GAing full support for IPv6. This is mostly to cater for large-scale clusters for telco and internet service providers. And as Adele has mentioned, we are tech previewing the ability to use OpenStack with host control planes, basically deploying a hub cluster on the quote-unquote admin project and running multiple node pools with multiple host control planes on respective tenant projects. Co-Red Hat OpenStack services on OpenShift feature release 2, which is aligned with OpenShift 4.18, we are introducing a new architecture which will distribute the control plane across multiple subnets leveraging BGP connections and will work in congestion to the availability zones, or basically the data plane, which is AZ aware. This would enable our customers to leverage a highly available architecture in a campus environment, further enabling the ability to create a robust and scalable IaaS infrastructure. Besides the quote-unquote Campus AJ scenario, we will also introduce Impact Preview, the ability to use multiple deployments on the same OpenShift cluster. Basically, utilizing namespace isolation, we will be able to deploy multiple Rosso control planes with their own respective permeable sets that will be deployed as data plane nodes, thus enabling the ability to consolidate environments, for example, for dev, staging, testing, something of that sort. And last but not least, we will also take preview the Watcher operator based on the OpenStack Upstream Watcher project. This will enable us to use basically to rebalance the workloads across our infrastructure, keeping the infrastructure and the workloads as optimal as possible. And on to Sachin for the next slide. So
thank you. In 4.18, we've added a new command called OCADM upgrade recommend. This improves the user experience for our cluster administrators while selecting update paths for their OpenShift clusters. So the key improvements are using this command, you can see the latest recommended version, and it gives you a clear information of if there's any risk or bugs seen in the upcoming version or the recommended version. And if you want to really distill down to a specific version you want to update to, you can use the subcommand -- version to get more clear information about the target OCP version. Please try this command and give us a suggestion of improvement. Over to Ramon.
So in the control plane, we have made some improvements so that you can hibernate a cluster, and that is install a cluster, shut it down until the day where you need to start your POC or production, and then restore the cluster. That will be the hibernation, and we support this for after up to 90 days of the cluster installation, or after our cluster has been running for some time, eliminating complex steps. We're going to see them in the next slides that you had to do up until now. Moving on to the next slide. So talking about control plane recovery. If you have ever tried to recover a control plane, you will probably have read the document that I link at the bottom of this slide, which is rather complex and long process, step by step, to recover a node, for example, that you lost as a consequence of hardware failure or otherwise. With this automation, what we are introducing is a workflow so that you still need an admin to enable this automation, but all these manual steps are eliminated. So we are reducing the complexity by a lot. If you read this document, you will know what I'm talking about. We are also minimizing human error, and we're actually improving even our own tests and our support to you, thanks to this simplification. Next slide.
Hi. So we consider security in layers. What does that mean is this feature is about revalidation of images, right? So what is that? When you get the image from your registry, that image is revalidated or can be revalidated at cluster level or at the namespace level. Next slide. CRUN is been a GA product for a while. We introduced in 4.14. Now what we're going forward in 4.18 is making it a default. What does that mean is it will be installed out of the box when you install 4.18. And also crun is not going away. It will be there. Runc will be there, but it will not be installed by default. Next slide, please. CLI Manager, it is there as a tech preview feature in OCP. Now what we have done is to address more use cases like disconnected. We have re-implemented the whole logic into an operator. Now you can go in Operator Hub, install it as an operator, and also now we can support disconnected use cases. Next slide and next presenter, please.
Thanks, Gaurav. On the networking front, we do have several noteworthy mentions, apart from the big one being the general availability of user-defined networks. The first up is support for Dynamic Configuration Manager for our default ingress. This feature is currently tech preview. So what this does is it helps you to propagate your endpoint changes through a dynamic API. So this enables your routers to adapt to the changes, either when you're scaling up or scaling down, without having to reload every time. And by also using this, you can reduce your memory footprint. Following on, for all the on-prem deployment on OpenShift, we now support an alternate to the configure OVS script. And what this does is it allows you to configure your BREX bridge to the exact specification as you need at install time. And you can modify this after deployment using the standard networking tools. This is now generally available. Next slide, please. With the introduction of the user-defined networks, or UDNs, like we like to call it, in OVN Kubernetes, we also provide observability for all the UDN network segments and objects assigned to those network segments. And this is done via, first is the OpenShift Networking Console plugin. And this will actually enable users to create and view your user-defined network seamlessly. You can also capture your network flows and metrics from your cluster, and users will be able to visualize these flows and topologies associated with UDNs using the network observability operator. This particular feature is currently under dev preview. For those of you who are new, the network observability operator is an independently lifecycled or an add-on operator, and the latest version is going to be 1.8, and this is going to release alongside OpenShift 4.18. Finally, we have the network observability CLI. This is a very lightweight, no prior installation needed, where everything is handled automatically. So you can basically run off your laptop command prompt, and this is basically used, primarily focused to make your debugging efficient. Significant enhancements have been introduced in this area with a 1.8 release, so please do check it out. Next slide, please. Thank you.
Thank you. We are excited to announce that Red Hat Connectivity Link is now generally available as an add-on to OpenShift based on the open source project Quadrant. Connectivity Link is built using the most cutting-edge ingress technologies using a WebAssembly plugin. It is designed to be highly integratable, meaning you can add Connectivity Link to other tools in your stack to create a comprehensive composable API management solution. As new rules, laws, regulations are passed around where data goes and lives, Connectivity Link integrates with the cloud DNS providers such as Amazon Route 53, Google Cloud DNS, and Microsoft Azure DNS to provide an intelligent and resilient routing structure and global distribution of traffic. It comes with an OpenShift Console plugin for governance, visualization of policies, configuration, and the topology of all your applications. Connectivity Link operates in a hub-spoke model across multiple clusters, which means an update to the hub will replicate to the spokes and follow a declarative state of configuration pattern. It is also a role-based by design architecture adhering to industry security standards. It's composed of many API resources that correspond to organizational roles of infrastructure owner, operator, and developer. This will allow cluster operators to define how shared infrastructure can be used by many different non-coordinating development teams while still adhering to industry standards. We hope you give it a try. And now I'm going to hand it off to Gregory and in storage.
All right, thanks, Chris, and hello, everyone.
So a fairly packed release for storage with quite a few interesting additions. So as mentioned earlier, we are graduating the Secret Store CSI driver to GA. On the VMware side, vSphere CSI driver now supports multi-vCenters deployment, as mentioned by Raman. Another good news, the very well anticipated SMB CSI driver is now GA. So this driver comes with two different provisioning modes, static for people who just want to simply consume an existing share, or a dynamic where volumes can be created dynamically as subfolders. On the Google front, we are adding hyperdisk balanced disk type support in order to manage the C3 and N4 machine types. For OpenStack users now, we are happy to announce that Manila CSI driver now fully supports as GA volume expansions. And lastly, we added automation to the deletion process for LSO local volumes, reducing the complexity to clean up the remaining artifacts such as symbolic links. Next slide, please. All right, now let's see what's new in OpenShift Data Foundation. So starting with disaster recovery, we are introducing enhanced support for complex application using recipes, as well as application consistency enablement. We're also adding key rotation for cluster-wide encryption. Now on the object storage side, we are adding an object border to the OpenShift console, and we're also introducing bucket notification to better support AI ML workloads. Last but not least, we are enabling a supported and easy way to set up storage classes based either on media types such as SSD or NVMe, but also on locality like is it SanDisk or local disk. And that is it for storage. Handing over to Frank to cover 5G and Edge. Thank you.
Thank you. In recent Red Hat OpenShift releases, we have delivered our image-based technology and methodology that permit, by shifting left, to prepare server in a pre-production environment, so we reduce the time it takes to install and upgrade single-node OpenShift at the far edge. But what if the server fails? While servicing subscriber? How to replace the server as quickly as possible to restore the service? In short, we will utilize our image-based install methodology depicted on the picture, so the new server will look like the old server. By doing so, we ensure that we maintain management and observability continuity. We plan to release a developer preview of our image break-fix solution with 4.18, and we encourage customer and partner to evaluate it and provide feedback. Next slide. Red Hat continues to make improvements to our advanced timing solution for RAM, which is mandatory to keep the edge node clock synchronized within few nanoseconds in order to avoid destructive radio interferences. In 4.18, we are delivering two significant improvements to our PTP stack when the node is acting as a grandmaster clock. The holdover feature on the left side of the slide allows the far edge to be more robust and durable in case of GNSS signal loss, as OpenShift can now maintain the time shared with listener as long as it stays within user-specified limits. The second mitigation feature on the right side of the slide makes OpenShift node to be more resilient to leap seconds, which are issued to adjust the coordinated universal time to compensate for Earth's variable rotational speed. Aside from these two significant features, Red Hat has moved its PTP operator to community to the Kubernetes network plumbing community. This is a strong endorsement of our solution and it will help streamlining contribution from third party. Next slide. As a software platform provider, one of our foundational mission as Red Hat is to bring our ecosystem innovation to our end users. When it comes to new CPU, the process always starts with Red Hat Linux support, meaning CoreOS support, meaning transparent support for Red Hat OpenShift as long as we expand our testing infrastructure and various CI with those new servers. However, this is not always transparent and certain OpenShift adjustments can be required. In this case, with servers supporting up to 512 CPU, we had to update our platform tuning code to address some hard-coded max value that were too low. It's important to note that we support this new AMD CPU with NPS equal 1, meaning 1 NUMA node per socket. Finally, thanks to to our close collaboration with AMD upstream, we are able to offer the last level of cache locality feature as a technology preview. This feature can allow application, typically but not necessarily DPDK based, to boost its performance by scheduling pod within a single CCX. Next slide, handing over to Daniel.
Thank you, Frank. So let's look at Red Hat Device Edge and MicroShift, which is our small form factor Kubernetes distribution for small edge devices. Let me highlight today 3 new capabilities. First, we have dev preview support for the new Kubernetes Gateway API, which is a new way to get traffic into the cluster. Second, we have a feature to automatically recover from backups. This increases robustness and avoids manual intervention, especially at remote edge locations. And third, we now provide a base image for RHEL image mode. That base image can be used with bootc to quickly start a machine with MicroShift. It also simplifies and speed up your CI/CD pipeline. Keep in mind, image mode is still tech preview, and we plan to GA this with 4.19 this summer. That's all for Red Hat Device Edge and MicroShift. Now back to the studio. Vanessa, please.
Thank you, Daniel. So we reached the end of today's presentation. Slides plus recording will soon be available. In the meantime, are you interested in getting to know OpenShift better, or perhaps completely from scratch? Take a look at our guided demos and learning opportunities, or you could start your trial and directly test it out. Moreover, you could benefit from the sessions that took place at various OpenShift Commons gatherings over the past months to learn more about specific topics. Quick reminder, the next in-person OpenShift Commons gathering will be held on April 1st in London, co-located with CNCF's KubeCon Cloud Native Con Europe. So are you an OpenShift end user? The call for papers is open until February 10th. There is still plenty of time to submit your proposals and ideas, so take a look. But most importantly, we want to celebrate Red Hat's end user community. So do you know any OpenShift user that goes above and beyond? You can nominate who you most value for their innovation, drive, and contribution. Basically, an OpenShift superhero. Winners will be celebrated at OpenShift Commons in London and at OpenShift Commons in Boston, taking place later on in May. Stay tuned for the upcoming OpenShift 4.18 release, official announcements, and related blogs. And with this, thank you for joining us today and sticking with us until the very end. See you all very soon and take care.